Hello everyone. Today we shall be discussing on how to calculate angular velocity of a circular motion. Now for an example, a light inextensible string of length 1.5 meter has one hand to fix to a ceiling a mass of 3 kg attached to the other end of the string. Perform horizontal circles such that the angle between the string and the vertical is 30 degrees. Now, calculate the tension in the string and the angular velocity of the circular motion. Calculate the tension in the string and the angular velocity of the circular motion. Now, to calculate the tension of a string and the angular velocity of a circular motion of a particle suspended on inaccessible string means that its length is not adjustable. It has a fixed definite length, which is 1.5 meter. That's good. Now, to calculate, first of all, we need to draw the schematic of what we are trying to calculate. Now, we were told that the particle or the mass 3 kg suspended at the length of 1.5 meter with an angle of 30 degrees centigrade. Now, from the geometry that we have here, we can see it's obvious that we have the radius and the tension pointing upward. Now, first of all, we need to use the formula of force, which is equals the product of mass and acceleration. Force equals the product of mass and acceleration. Secondly, we need to use what we call horizontal equivalent of acceleration, which equals the square root of angular velocity multiplied by the radius suspended. Once again, our angular acceleration equals the angular velocity squared multiplied by the radius. From there, we can resolve that our force will equal mass times angular velocity raised to power 2 times the radius, which equals T, which is tension, sine 30 degrees, which is the angle given. That gives us equation 1. Now, vertically, for us to resolve our vector here, which is suspended at the angle, vertically, we know that our mg, which is mass times gravity, our g, which is 9.8 meter per second squared. We know that mg equals tension T multiplied by cos 30 degrees centigrade degree. Now, our geometry will equals R equals 1.5 sine 30 degree. From there, we arrive that m times the angular velocity squared times 1.5 equals t. That is equation 3. Now, if we substitute our equation 3 here into equation 2 here, we arrive that our mg, which is mass times gravity, which is acceleration due to gravity, equals 1.5 times mass times angular velocity squared cos 30. From there, we can find out our angular velocity, which is W, by interpolating the equation here. Then we can arrive that our angular velocity, which is W, equals G all over 1.5 cos 30, all into square root. By squaring every entity here using our calculator, we arrive at 2.75 radians per second, which is our angular velocity. From there, to calculate our radian per second, to convert our radian per second to revolution per minute, then we multiply our 2.75 radian per second by 60 over 2 pi in revolution per minute. This now gives us 26.2 revolution per minute. From there, to calculate our tension becomes T, which equals mg over cos 30, which equals 3 product of 3 and 9.81, which is our acceleration due to gravity, all over cos 30, which gives us 34 Newton. 34 Newton. So our tension acting upward due to the suspension of this our particle is 34 Newton. Our tension equals 34 Newton. Thank you.